Welcome, dear students, to this first video on the chapter Computer Organization and Architecture. Today, we are going to introduce the chapter and see and understand what we mean by the stored program concept. Okay, now, computer organization refers to the physical organization, in bracket implementation, and operational details of the hardware components of a computer system and to the characteristics of these components. It includes the high-level aspect of a computer's design, such as the memory system, memory interconnect, and the design of the internal processor or the CPU. So this is what we refer by computer organization. That is the implementation and the operational details of the hardware component of the computer system and the characteristics of these components. Now, a computer takes data as input from the user and processes this data under the control of a set of instructions called programs and gives the result as output and can store the data for future use. That is exactly what a computer is doing in some simple terms. It takes data as input from the user, it processes the data under the set of instructions. We call those instruction programs or softwares, and it gives the result as an output, or it can store it for future use. Now, this is the basic diagram of the functioning of a computer system, of a computer, if you want. That is, data is being entered with the use of the control units, of the input unit, sorry, input unit, that is, these are the units that are responsible for taking data from the user and entering them into the computer. From there now, once the data is being entered, they need to be stored in order to be used. And that is when we use the storage unit, where we have put the secondary storage, those that store for a long period of time, and the primary storage, those that are easily accessible by the processor for fast computation. Now, the storage unit communicates with the central processing unit because this is the brain of the computer. This is the sector responsible for the management and the control of the different computation. And we see that the central processing unit is made of the control unit and the arithmetic load unit. In the future lesson, you shall see that there are other units that are present here. Now, after the different computation are done, because you can see here we are fetching data and here we are saving the result of the computation. From there, you see that this line comes directly because this is the unit responsible for executing. From there now, from what was stored, we use the output unit in order to send out information. As you can see, that one the arrow indicates the data flow, while this indicates the control flow. So basically, this is the diagram that simplifies the functioning of the computer. The machine part of the computer consists of physical components called the hardware. So this particular unit, this unit and this unit comprise of what we call the hardware. Although there are some units here that are also member of that can still be called, that contains components that are part of hardware. The program part consists of intangible components called the software. So when we're talking about the set of instructions under which data is being processed, we are referring to this, the software. This combination of hardware and software form the computer system. Computer architecture refers to the structure and organization of a computer system. It specifies the components that make up a computer system and describes how they are interconnected, how they interact with each other, and how they are managed. That is simply what we call computer architecture. Structure and the organization of a computer that specifies the components that make up the computer system, and also it describes how they are interconnected, how they interact with each other, and how they are being managed. Okay, the stored program concept. In the early days of computer systems, programming was performed by manually setting the position of a large number of switches and plugs and then entering the input data, and the output was produced by determining the position of some of the switches. In other words, programming was very tedious in the early days. It was very tough to perform or to write a program. The main issues of this approach was that reprogramming through setting switches was very inefficient and time consuming. This issue was solved by a model called the stored program computer model. So the stored program computer model is that model that was being built to solve the problem of reprogramming that programmers faced in the early days. It allowed for instruction to be fetched from the memory unit and executed one after the other by a processing unit that was designed to perform arithmetic and logical operation. This meant this meant that machines could be more versatile. Very important. So the stop count concept enabled instruction to be fetched from the memory and executed one after the other sequentially by a processing unit that could perform arithmetic and logic operations. Also, different programs could be loaded onto the same machine and this machine will perform different tasks. This concept paved the way for the creation of general purpose computers such as modern day smartphone, tablets, laptop and desktop computers. So these different computers, these different machines you are using today are mostly built on the stored program concept because it allows the machine to perform different tasks. As your phone you are having today, you can perform your online streaming, you can do calculations, you can view, you can listen to music, you can do your research. It performs a lot of tasks. The stored program computer model is based on three concepts. These are the fundamental concepts on which the stored program computer model is based on. One, data and instruction are stored in a single read-write memory, meaning that the data and the instruction being used by the computer are stored in the same memory. The contents of this memory are addressable by location without regard to the type of data contained there, meaning that the memory where a particular data or instruction is being stored has a memory address which the processing unit uses in order to access it. That's why we say the content of this memory are addressable by location. Each data or instruction being stored in the computer has an address. And next, execution occurs in a sequential fashion unless explicitly modified from one instruction to the next. So, execution in the stop count concept occurs in a sequential fashion, that is one after the other. The first electronic computer that applied the stop count concept was the Manchester Baby, made by the University of Manchester in 1948, which included the first type of random access memory. So guys, this is the summary of the stop count concept. You saw the three fundamental concepts on which it is being based: data and instruction stored in the same memory, which is both read and write. The contents of the memory are addressable by location, and finally execution occurs sequentially. In the next video, we are going to look at the fundamental architecture which makes use of the stop count concept, which is the von Neumann architecture. We shall describe it and show how it works. Thanks for watching the video. See you in the next lesson. Do not forget to like, to subscribe and to share our video in order for our community to grow. Thank you and see you in the next lesson. Bye. Bye bye.